My name is Toliver, Jao Toliver from PlanetScale. I'm a software engineer. And this is Jiten. Jiten is the CEO of PlanetScale. So if you have any questions, you should just ask him. I'm here just to look pretty. Yeah. Better. So today we're going to talk about Vitess, and this is called stateful storage on Kubernetes. 听过的 Vitess 听过的人是谁啊？用 MySQL. Who uses MySQL? Okay, that's good. So maybe this is for you. So anyway, okay. 坐这里可以 Okay. Plenty of seats. All right. So what is Vitess? Vitess 是什么, right? It's a sharding middleware for MySQL. Sharding 分片, I think, 分片, something. And what's beautiful is that it's massively scalable, and it provides high availability, like 5 nines availability, and it's cloud native, so Kubernetes, etc. How many people use Kubernetes? How many don't use Kubernetes? No Kubernetes? Okay, everyone's Kubernetes. Oh, even better. Great. So who uses Vitess? 谁用Vitess? So this cache app is Square Cache. That's like Weixin the Pay, but for US. Also YouTube. Vitess came from YouTube originally, so they use it. Not Burger King and not Instagram yet. But those are like the top apps in the US, and so they're using it. So here are some of the key adopters. Okay. So how many have heard of JD, Jingdong? Yeah. So Jingdong uses a lot of Vitess. They're one of the biggest users in the world of Vitess, and they have 3,000 or more databases, and they have 18,000 or more tablets or MySQL instances. So more than just one. So many. And maybe you guys don't use Slack as much, but Slack, even them, at least one quarter, 25%, have changed to Vitess. So all the chatting is saved in Vitess. Again, before Square Cache also, and Pinterest. I don't know if you know what Pinterest is. So Pinterest also uses it for a lot of their advertising. So yeah, so these are some of the many adopters. And as there are adopters, there's also lots of people contributing, changes, PRs, and so includes lots of these companies. And they all, of course, are using Vitess in production. Am I speaking too fast, too slow? Okay. 没问题吧? All right. So yeah, I want you to think from now on, if you think Kubernetes and you want to store stateful storage, I want you to think Vitess. Okay? Why is that? There's actually someone, some famous internet person who says, if you want to run stateful applications on Kubernetes, you're pretty stupid. It's too hard. And we agree, it's not easy. But and the reason is, one does not simply move MySQL to Kubernetes. Because if you just try to do that, you're going to run into many problems. Your pod's going down, your whatever going down. Everything goes down, right? Who has a service that's perfect, never goes down? Anyone go down at all? Okay, people who go down, raise your hand. Only 3 people have problems? Okay, then you don't need anything. You're perfect. So just a few things about Vitess. Vitess started in 2010, and that's when YouTube, who knows what YouTube is? It's like Youku for not China. Okay, so yeah, so YouTube had started running into scaling problems with MySQL. Like many of you, they had just one super big MySQL instance. Of course, they had some backups and some replicas, but they had too much traffic, and probably many of websites in China, Vietnam, you guys have lots of web traffic. So YouTube ran into some problems, and then so they needed to deal with it, and they have big apps, right? They don't want to rewrite. So Vitess, since in 2010 there was no Kubernetes. Kubernetes is 5 years old now, and Vitess is older than 5 years old. So, but it was designed for Borg. So Borg is the precursor, the Google precursor to Kubernetes. So Vitess, I think, so Vitess was designed really for Kubernetes as well, because it's all the same ideas. So yeah, production workloads. So besides YouTube, of course, Stitch Labs is the oldest one. So they started using in 2016, a few years ago. And then HubSpot has many key spaces, or maybe databases, as you may call them. And JD has 3,000 databases with, as I said before, 18,000 E1 Batian tablet dual, right? And they have, I think they said 67 shards now, 67分片 or something, on their largest. They have many databases, but that's just their largest one. And then there's another company here, Nozzle, and they migrate even between the clouds. So here you have Aliyun and you have Huawei Yun or something, and you want to migrate from one to another. So they do that. So you don't have to be tied to one cloud. So this was what I thought it was coming after. So MySQL before, right? It's an old software, very good, but they merely adopted the cloud, whereas Vitess was born in the cloud, right? It was made for Borg, which is before Kubernetes. So the whole point is it is cloud native. Like it did not exist without the cloud. So here is the concrete architecture of Vitess. How many of you guys are running apps that are connecting to MySQL? Everyone? Yeah? Okay. I'm going to stand over here. Is that okay? Yeah, okay. So the general architecture, Vitess tries not to break anything. You have big apps. They're running lots of traffic. You don't want to break anything. So before, you have your app servers here, right? And they used to talk to a big MySQL database, right? And they use MySQL binary protocol to connect, right? But Vitess is all of these blue, purple color. So they're this part and these parts. So it's a proxy to all the MySQLs. And under the covers for saving the data is actual MySQL. So you guys, we can actually migrate your MySQL workloads into Vitess actually pretty easily. So what's important here is between the app server and what is these VT gates. These are the proxies. They speak MySQL binary protocol right here, MySQL. Okay, and there's a custom protocol here between these blue parts, and then all of these, this software, the tablets, connect to actual MySQL instances under the covers, and they only talk this way. Does that make sense so far? Good. All right. So, but why would you want to use Vitess? I mean, not everyone has, Jingdong size workloads, or YouTube size, or Youku workloads, right? So why would you want to use it? I mean, if you have a small workload, so what are the benefits of using Vitess? So this was your DB right now, right? Works just fine, it's all good. But you can actually already put Vitess in between your main DB and the app servers. And when you do that, it provides automatic connection pooling. It does deadlines, like if you have very long-running queries, if you have an analysis. It also provides hot row protection. So if you have many apps trying to get exactly one row, it will stop and pause that while giving other people quality of service, good quality of service. It also, enforces row count limits, so not too large queries. And it can also blacklist tables. Like if you don't want certain applications to access certain things, you can, because it's a proxy, it can also say, oh, I don't want you to access this, and you can cut off usage. So even for smaller workloads, it's OK to use this because it provides benefits for your application developers. Sometimes they make mistakes, have bugs, and then it won't take down the database for everyone else. Does that make sense? That's for smaller workloads. But then once you've put it in, you now have some more benefits as you start growing your workload. So again, before you had only the single database. Maybe you had a few backups or replicas. But with your growing workloads, you had your previous main database, the master. But with Vitess, since it actually can parse all of the MySQL SQL, it can actually decide to be smarter. It can do replica routing. It can decide, oh, all you're doing are select statements, and decide, oh, you don't need to access everything. So you can go straight to our replicas to actually do the selects. And thus, it can also do load balancing. You have more connections and whatnot. And you can then use Orchestrator as well if you need high availability, HA, to do failover or promotion. So you can choose one replica. Oh, I want this one to become the master, and you can swap them. And to all the apps, it's invisible. So it's just all natural. So remember, MySQL protocol only happens here. And then, this is only management DBA access. Does that make sense? So yes, this is why, as you're growing the workloads, if you have a lot of read traffic, you can add more replicas. No one knows the difference. And now you have even more traffic, or too much data to fit on one disk or many disks. So you can do a few things. And so with the growing workloads, I can split. Before, I had only main DB. We'll call it DB1, right? And you had all of the traffic going there. And so you had to have a disk that's big enough for all of your data, right? But now we want, imagine you have two big tables. They're growing big, and then they're going to blow up in one table. So why don't we split them into two different ones, right? So with this, you can split table 1, which is big, into, keep it in database 1, and then you have the other big table, table 2, moving into database 2. So yes, you have now table 1 in database 1 and table 2 in database 2, but to your application server, because again it's proxying, you can have a unified view. You can see both table 1 and table 2 like they were all in one big MySQL. So, and again, just like before, each of the database 1, you can have many replicas, and database 2 has different numbers of replicas. Make sense? So also you can, with this proxy, you can do key space subsetting. You can decide your application can only see table 1 and table 2, and different application can only see table 3 and table 4. So you can split that way too. All right, and as you grow even bigger, remember table 2 was here, but table 1's growing really, really fast, right? And maybe you're a big e-commerce website like Jingdong, and they decide, oh, we have too much write traffic. We have too many orders happening all the time. And so table 1, it can be horizontally sharded. So in this example here, we see 3 different shards. So just table 1, we can split into 1/3, 1/3, 1/3. And it will go to separate instances. So you can have now 3 times the write traffic, and you can still have many more times also the read traffic, and you can control that quality of service there. And whereas table 2 didn't grow very much, it's pretty constant, but still big, and it will have a different quality of service right here. But again, to the app server, it will all still look like one super big database. Make sense so far? Good. So, and then you get really, really big, right? So this is, again, a Jingdong style one, and they have, and not just Jingdong, but many other companies, also have, before, it was all in one big data center or one availability zone. And now, when you have the massive workloads, you don't want, one bomb to break the data center. You want to be able to handle the failure, right? So we can split, even with a single shard, into different availability zones. So this gives you other high availability options, right? Before, it was only for the reading reason, but now, in case one goes down, we can split and have more high availability. Here's zone 1, 2, and 3. Yes? Vitess will handle, sorry. Yeah, MySQL connects the actual
So you
replication.
replicated the data through the MySQL binary? Yeah, okay.
Yeah. Other questions? Does that
No.
answer your question? Okay, cool. All right. Thank you, Jiten, for answering. So yeah, so even as you go really, really big, you're going to need extra high availability, and that's the benefits here. Okay? So, some demo time. This demo is very simple, very stupid, but everyone can run it on their own laptops. And I'm going to demonstrate by running on my laptop. So, this is a schema, marketplace schema. It doesn't really matter. It's just got 4 tables. My actual demo only has 3 tables, but whatever. Same idea. This was all one big main DB. And we have a product table, customer, orders, and merchants. But in my demo, we only have less. OK, so I'm going to demonstrate this. I have already brought up a let's show databases. So this is actually MySQL. Let's see, make it bigger. Can you see? Is it OK? Yeah. So I just brought up a MySQL. I actually brought up 3 instances of MySQL and behind Vitess. And if you see databases, we see only a commerce database. And inside commerce database, we actually see 3 tables here. Something called order. It's called C order, but order, customer, and product. OK? Make sense so far? And I will show you there's some data in this, in each of the tables. It just showed all the tables. OK? But all right. So that's just the data, the current one in the main DB. OK? So next, maybe again I said table 1 and table 2 got too big, and maybe wanted to split into two databases, one DB1 and DB2. So here, when we shard, we can decide, oh, all of the products go into one database, and we'll make another customer database, called customer and orders. So we'll move 2 of the tables from the original main DB into a new one we'll call customer DB. Does that make sense? All right, so how do we do that? Good question. I have no idea. Okay. We have some scripts here, and these are actually on the Vitess website tutorial. So you guys can get the code from Vitess and actually just run these tutorials yourself. It's exactly the same. I'm just showing you. Okay? So let me show you what we're doing. So sorry if this is too small or can't read. These are actual commands from Vitess. I'm just showing you what's in the scripts. It creates a key space. Key space is a database like database 2, named commerce, and it says to route all of the traffic for it. Customer. I'm making a new customer database, but all of the traffic for the customer database actually goes to a place called commerce, the old database, the main DB. Okay, so I'm only just going to run this command here, and it's done. And then there's a few other things. The next command I'm running just brings up more instances of MySQL, 3 more instances for the tablets. So here we go. Literally starting MySQL. I will now talk to wait for the time. So it's just bringing up more. But of course, while I'm accessing this, again, I can still see all of the all of the data from the original main database. Nothing's changed, right? As I wait for that. And the point is, in these steps, we're bringing up new databases, and then we're going to slowly move the traffic from seeing all of the data in main database to a different one. But all is it's invisible to the app server, in this case, the MySQL client. So as you can see here, it's bringing up MySQL and also bringing up the little tablet that's attached to each MySQL. And yeah, OK, great. So it also has set a master in the new database 2. And so we'll see this working, hopefully. Let's see, show databases. Oh, look, we now have 2 databases. Before it was commerce only, and now we have customer database. And so, give me a second. OK, before I do that. So I'm going to go to the customer database, right, and show what tables we have. We have some tables, but so all the traffic for if we wanted to select from the customer database, it will look like it came from the other database, or it will behave like it will come from the other database, but it looks like it's also available in this in database 2, the customer database. Okay, sorry. So from there, and I can still access, as before, all the data. Let's see. Okay. So actually, now, before I was getting all the data from the database 1, the main database. But now, my new script, just gets the data from the second database, and it shows that it's available there as well. Okay. And now, one of these scripts here is vertical split. So vertical split is the moving of tables from database 1 to database 2. I can show you the code here. It's literally just one command. The rest is environment variables that is splitting off the data. So it's doing some stuff. What did it do? Who knows? Let's see. So what it actually did there is, again, we had new empty databases, and it copied all the data from one to another, and then from there continuously replicates from, even if you write to table 2 in old database, you will start seeing it in table 2 in new database. So it sets up, it does the copy and then replication from then on as well. So that is what this command just did. So still nothing different here. Actually, again, we haven't moved any pointers for what data we're reading. We're still reading from the old database, even if you now, as you change your app, go to read from the new database. So the next step here, is it visible? At the bottom. OK. We're going to migrate where we read the data. So kind of to go back here, yeah, kind of here, right? Before it was pointing originally, all of the queries were going here. But now we're going to actually say, just for the replicas, the read-only, or the reading traffic, hey, let's go read from here and not here anymore. So we can, there are independent pointers to go, instead of pointing from here, point to that one. So the inside the shell script, it's just saying move both the read-only and the replicas over, say, but not the master yet. So this is all the read traffic. So migrate, select customer 0, still looks the same. Remember, if it all looks the same, that's good. If it's not the same, then something's wrong. So yeah, still selecting, no problem. And then our last one is migrate the master. So migrate the master, same command, only instead of saying read only or replica, it says master. So master is, you've decided to change all of your writing traffic over to your new place. Okay? And by the way, before we even do this, right now I have moved my read traffic from replica read only, right? I've moved it here, but maybe I have a problem. Actually, you can still reverse because this is a pointer. So you can decide, oh, I want to reverse, and I can go back to reading this. So in case you're worried, you can try it, and if it has problems, just move it back. And then you can debug, try it again, no problem. So, but once you move the master to the new one, well, now all of your stuff is there. So that's what we're about to do right now. Migrate the master. Pretty fast. Even in production, this should be a very fast switchover. Maybe a 1 second or less delay, just to propagate all of the configuration information. Because again, all of the replication, all the copies have been happening all of this time. Okay? So I've migrated the master. I can still see that. Everything still looks OK. That is the whole demo, by the way. It's not very much. So we went from one big database to splitting it, in this example, splitting off tables. It can do horizontal scaling and split that way too. Just don't have time to actually show in this example. So how does all of this work under the covers? This is actually one of the keys of Vitess. We call VReplication, or Vitess replication. It is filtering all of the replication. So as you see here, originally we had some tables here, and we can set up different types of composable replication, whatever, and we can have, for example, the order information propagate over this way. This is a horizontal shard example right here. This is for what's called the different shard names. It's like half of the traffic go over here, or half of the traffic go over here. So because this might have two shards, split, shard one, some of the row data, and split the other half. So it's all doing filtered amounts of replication. So it's not doing everything. So all of this is composable. Oh, yeah? When you have multiple shards, how do you handle joins? Good question. So the question is whether you have, actually, do you mind if I answer that right at the end? We're really close. If this is going too long, forgive me. Does this generally make sense? So with this VReplication, these are the benefits. You can have materialized views. You can have real-time rollups. Resharding, again, before was actual examples of resharding in real time under the covers. Backfilling of lookup vindexes. So vindex is a Vitess index. It's how you decide which shard to go to when you're looking up data or inserting data. And sometimes your primary index is not what you want. Like you have authentication table, you have a user ID, maybe you have user email. If you just want to look up where your given email is, you need to also figure out which shard. So the secondary lookup index, the vindex, is what that's for. Also, it allows for different schema deployments and data migration and change notifications in general. So the beauty of how all of Vitess works, especially is with this VReplication to do all this sharding and to keep everything in sync. Does that generally make sense? All right. All right. This is the end of the talk. I'm just going to say some things, and then we'll open up to questions. Is that OK? All right. So yeah, we have a Slack channel that's at vitess.io. Vitess.io is where the open source project is hosted. We have a WeChat group. You should come to us only because WeChat has problems with more than 100 users at a time or some other limits. So come to us. We'll add you to the WeChat groups. Also, this was the introduction talk. And Jiten over here will be giving another talk, a more advanced one, on when we actually bring down, for disaster recovery, bring down shards or bring down masters and et cetera, what happens.
Bring down masters, we are going to bring down a whole data center and show you how resilient Vitess is. It's room number 629 at 125.
Yeah, I can edit this to show you that. And then also, we're going to have another talk about translation of documents for Vitess. Right now, unfortunately, all the documents are only in English, so 对中文说的不太好吧. So it would be great if we had some translation stuff, and so if you would come by with that, we can talk about how we are going to be doing that. Also, just like I'm running on my laptop, we would love for you to try bringing up a cluster on your own laptops, and we can help you out with that. Read the code, and you can read some blog posts from Square Cache about their deployments of Vitess, all the problems. And actually, even Jingdong, they just gave a talk on other problems and how they solved them with Vitess. So you can, and this person here can talk about them if you're curious. I'm on Slack on the Vitess Slack channel as @Toliver, and I know Twitter not accessible, but if you can access it with VPNs or whatever, you can use these things to access. Does that make sense? All right, so open to questions now. Sorry, whoever you are. Sorry. Can you repeat your question? Can you? Yeah.
Points when you have sharded tables, vertical and horizontal.
Right, good question. So the ideal case is you don't do anything wrong, but you have single shard stuff. Like if you have a user table, authentication table, you can co-locate, like based on user ID, like all the user ID data for both tables be in one shard. That's the best option. But of course, once you go across, how do you handle that? So we have, what's it called? 3 modes, or 2 modes here for cross-shard, what's it called? Cross-shard transaction modes. We have a best effort, where you can have each one independently transact, and of course you have the default, or not default, the 2-phase commit option. So it can 2-phase commit across. That's for inserts, but for joins as well. Let me go back to the architecture diagram here. Here we go. Yeah, so you see actually that VT gate, the proxy, actually does talk to all of the tablets. And remember, it does parse all of the SQL, and it actually also collects all of the results from all of the different places and can do all your joins at that place if necessary. Does that answer your question? Yeah, so yeah, because each gate goes to all the different tablets. So, and remember, there's not just one tablet here. You can scale this. I think Jingdong, you guys have like 1,000 VT gates or something like that. So it's not just one. You can do many more than one. Does that answer your question? Okay, great. Any other questions? Yes?
I have a multi-master cluster replica from Amazon to Alibaba. So I want to use Vitess. So can I migrate to it without downtime?
Jiten, do you want to answer this one? Let's.
You have a master in Alibaba, and you have a master in Alibaba and a replica. In AWS, and that one is running in EC2 instance. Okay, and what is it that you want to achieve?
I want to still maintain multi-master.
Okay, so Vitess does not support multi-master, because multi-master is not a great architecture in our opinion, because it can lead to issues when you have writes going to both the masters and they need, if there are conflicting writes. So for a given shard, we always send the writes to a single master. So even if you have a multi-master architecture, your writes would go to one or the other, and we would allow you to fail over to start sending writes, say, from AWS to the other one or vice versa.
Yes, the case we use the multi-master because we have the user in China and we have the user in our China. Like some China user, Chinese user, so they want to access our web application. So they just insert the data into the database in China.
Okay, so that's why you don't have any conflicts, because you have tenant-based
something like that
architecture.
But we still, for the manager, so they have to outside, they need to see the data of both. Right. So that's why we have.
I mean, I will answer a more general question, which is that you can run your masters in one cloud, replicas in other cloud. You need to make sure that you have an IPsec tunnel through them so that you're not sending packets unencrypted across public network.
Yeah.
But you can fail over. Vitess will allow you to fail over from from one cloud provider to another, and will also allow you to spin up clusters across cloud providers.
Yeah, understood.
Actually, we can actually talk about the sharding, right? I mean, you can actually shard based on your tenant. You are saying that there are some Chinese users, right? And so you can have them in one shard and others in different shards. And remember, each of the tablets, each of the masters, you can individually select where they are. So again, you can have the unified view, but again, based on this one, you can actually have a custom sharding scheme. You can write your own sharding mechanism. So if you know that user 1 is a China user, user 2 not China user, you can shard in that way. Does that make sense? Okay. Yep. Oh.
I want to ask about because I see that you moving out a table to the database. So I want to understand. So what thing need to be changed in the application to the for example, we have the version 1 collect to the database with the table.
So,
But we have the version 2 collect to database, collect to the
that's
table as the
that's the
database.
beauty of Vitess, right? As long as the name of the table is if the name of the table does not collide between key spaces, your application doesn't need to know. Your application just can continue to write to VT gates, and VT gate will send those writes to the correct database where that table exists.
So-
as long as both key spaces don't have the same table name. If there is a same table name, then you have to specify it in the table name.
This is the unified view. So it looks like just one big one, but
Yeah.
under the covers, there's a database 1 and a
Correct.
database 2.
So if DB1 had table 1, table 2, and you moved it to DB2, after that split happens, your app
okay.
doesn't need to change at all.
Okay, I see. Thank you.
No questions? Oh, yeah.
If I'm very concerned about the latency, so why how Vitess can help me? I'm very concerned of the transaction latency.
Correct. So transaction latency at high write volumes is what you're worried about, right? Yeah. So Vitess itself adds a little bit of latency to every query or every transaction, because you have to do, if you go back to the architecture diagram, there are 2 network hops that it has to do, right? Your application is connecting to VTGate, from VTGate it's connecting to VT tablet, and from VT tablet it's connecting to MySQL D. So it adds about 4 to 5 milliseconds of latency to every query. But because you can horizontally shard, your write QPS on every master is a lot less, and that's why your latency ends up being a lot less than it would be if you were writing on a single large master. Does that answer your question?
So yeah, it may add a little bit of latency to any single query, but it will increase your throughput by quite a lot. Does that answer your question? Okay. Any other questions? All right. If not, thank you very much for coming. Again, I'm Toliver, and this is Jiten, and we're from PlanetScale. We do Vitess things.
And I think we have some Vitess stickers here.
We may have a few, but not too many, unfortunately. Anyway, if you have any other questions you'd like to talk in private, feel free to come over. Probably outside. I think the next talk is coming. Okay? Thank you very much.